2006 question 2, relative velocity. A boy swims due west at a speed of 0.8, given this diagram here. And a girl swims 0.4 meters per second in the direction alpha degrees, south of west. She's going in this direction at 0.4. And at a certain instance, she's this 10 meters here, 60 degrees north of west of the buoy, and 10 seconds later she's due north of the buoy. So why don't we let this point here and here be 10 seconds later? She's due north. So what's happening in that 10 seconds? That's what we're asked first. How far do they travel? So part 1, first 10 seconds. So the buoy is going at 0.8, 0.8 by 10. He has traveled 8 meters, and the girl is traveling at 0.4, so she has traveled 4 meters. So we can add to this diagram here. We have a 4, create a right angle here. We have this height here if we need. We can create a right angle. We have the 60 and we have 10 on that triangle. And now we have these distances at the bottom. We have 8 total. And we can take some of these diagrams. So we're looking for the value of alpha. Okay, let's get some information into this question. We can definitely use the 60 that we're given, and the 10 on the hypotenuse, to find out x and h if we need. So x, we have the hypotenuse, so 10 cos, x is adjacent, 10 cos 60. H is going to be 10 sine 60. Sine 60 is equal to root 3 over 2. So 10 root 3 over 2 is 5 root 3. And 10 times a half is 5 cm. And we have the whole bottom is 8 actually. So we have 5 cm here. So this would have to be 3 cm, which we could add up onto this diagram up top here. That's 3 cm. And that's enough information to get alpha. The cos of alpha, we have a and h. The cos of alpha is equal to a 3 over 4. Therefore alpha, the inverse cos 3 over 4 is giving me 41.41 degrees. That's alpha. And then the shortest distance between them in subsequent motion. So we need the velocity of one and the velocity of the other and the relative velocity. So let's look at the velocity of the buoy first. The buoy is just moving west in this direction at a speed of 0.8. So the velocity of the buoy is in a minus I direction, minus 0.8 in the I direction, plus 0 in the J direction. The velocity of the girl she's traveling at 0.4. She's going in a negative direction. The girl down in this direction. Negative 0.4 cos A in the I direction. Negative 0.4 sine A in the J direction. That's going to give minus 0.3 in the I direction. Minus 0.2646 in the J direction. So the velocity of the girl relative to the buoy is going to be the velocity of the girl minus the velocity of the buoy. Do it the other way around. So 0.3 minus 0.8 is going to give positive 0.5, and then minus 2646, and then there's a 0, so just minus 0.2646 in the J direction. So what we have our diagram here, we have a girl up here, she's 10 meters away from the buoy, so we need that to be our hypotenuse. We have the girl on the buoy. The velocity is positive, negative. The relative velocity will be going down in this direction, so we have to connect our line to give us a right angle, which will be say here. So we need to know the angle, which actually is going to be in here up to the x-axis. So the inverse tan of of 0.2646 over 0.5 will give us this angle in here. That's going to be 27.89 degrees. Now, based on if I do another right angle down here, or another straight line down here parallel, we have this one was 60, she was 60 degrees away in that direction. So these two in here are 60, these two are 60, and we have this one is 20, let's say 28, this one is going to be 32.11. So we're looking for the shortest distance here, x. So opposite 32.11, x is going to be equal to the hypotenuse with a sine of 32.11, or you could set it up the long way, the sine of 32.11 O over h, which will be your x over your 10. So x, the shortest distance here, 5.3 meters.